Number 23 on page 200. This is a tangent segment. And then we have a secant segment. And the rule is you take the outside times the whole length of that segment equals the outside times the whole. So for this secant segment, the outside portion is 2x. We're going to multiply that to the length of the whole thing. How do I represent the length of the whole thing for number 23? 2x plus 10. Okay? That's going to equal the other segment. Same rule. Outside times the whole thing. What is the outside portion's length of this tangent segment? And what is the whole length? It's also 3x. I suggest that you get in the habit of writing that out. Because when you write this out, you will see that the product of 3x and 3x is you should get 9x squared. Because if you looked at the notes and you said, well, we just take that value, whatever the length of the tangent is, and we square it, and this is all you did, you need to know that you are squaring that entire value. 3x times 3x. So 3 squared is 9. And then x squared is x squared. But if you write it out, like I've always been doing, that'll help you a whole lot. Here I'm going to distribute the 2x. 2x times 2x is 4x squared. Just like over here, 3x times 3x, 9x squared. Very similar. Then 2x times a positive 10, I get a positive 20x. All right, so now for this one, some of you saw this equation and said, okay, there's a variable that's being squared, and then there's the same variable being raised to the first power. What do we think of? Quadratic, okay? So that's completely legitimate if you see that, and that's fine. Then some of you just said, well, I've only got 2 different types of terms. I've got some that have an x squared, and I've got one that just has an x. So there's not 3 different types of terms. And so maybe you didn't see the fact that this is a quadratic because there's no constant, there's no normal number in this equation right now. So maybe those of you who saw that, you subtracted 4x squared from both sides of the equation and got that 20x is equal to 5x squared, and you continued solving it that way. And that's fine, but you have to realize that the value 0, that satisfies this equation. So x could equal 0. When I plug in 0 for x right now, that satisfies this equation. Because 0 times 20 is 0. And that equals 0 squared, which is 0, times 5, 0. 0 equals 0. So 0 is a solution of this equation. And when you solve this equation this way that's currently written on the board, it's not that obvious. And I don't think your Algebra 1 teacher talked to you that much about how 0 is a solution when you get down to here. Okay, so some of you may have divided by x and divided by x. So yes, those x's cancel out, and then this x squared, when you divide it by x, that squared goes away, and so you're left with 20 equals 5x. That's true, but you have to understand, when you divide by x on both sides, like you're losing the fact that 0 is a solution to this equation. And we're not allowed to divide by 0, so that's why it kind of fails. So we can't divide by 0. So a lot of you that did it this way, and maybe you just divided by 5x on both sides. Maybe that's what some of y'all did, divided by 5x, and you got x was 4. Well, that's good, okay? X equals 4 is one of the solutions to this equation. That's true. But I just want to make sure that you realize that you're missing another solution. When you get to algebra 2, that's not okay. That you're not recognizing that there's another solution to this equation. Okay? And I hope, I really, really hope that all of you guys go to pre-AP Algebra 2 with Mr. Crowley. He's an awesome teacher. You guys will love it. Yeah, he won't let that fly. He's going to make sure that you know that 0 is the solution. Okay? So let's take it back here. And so maybe some of you saw that this was x squared and x raised to the first power. You thought quadratic. I need to set this thing equal to 0. Good. That's good. Let's do it that way. I'm going to subtract 9x squared from both sides, and I get a negative 5x squared plus 20x equals 0. Is my leading coefficient a positive 1? No. What is it right now? It's negative 5. So what do I need to do to both sides of the equation to make the leading coefficient a positive 1? Divide by negative 5. Now when you guys get to algebra 2, you're going to learn new methods of how to factor these and how to get the solutions. But we're going to stick with this one, make sure that the leading coefficient is a positive 1. So I'm going to get x squared minus 4x. So you see that? X squared and then positive 20 divided by negative 5, that's negative 4x. Okay. And we have already had this thing set equal to 0. So the issue is the standard form of a quadratic equation is ax squared plus bx plus c. We don't have, right now, we don't have a plus c. We don't have that constant over there. Is there any number that I could just add in there but not change the value of this equation? What's up?
0.
0. I can add 0 all day long, and it's not going to change anything. So the value of c for this quadratic is 0. It is 0. So we ask ourselves, okay, well, what two values can I make the product be 0, but sum up to be a negative 4? And again, this is where, last class, where one of my kiddos, they said, well, how do you remember which one is the sum and which one is the product? And so this is what we got right here. We talked about how when you distribute, I get x times x is x squared. And then I'm going to have a b times x when I multiply those two values. Then I'm going to have an a times x. And so in the end, you know, we combine like terms, we add those. So the coefficient is going to be whatever a plus b is. And then this last value is whatever a times b is. And so this is what helps me remember what numbers I need to make sure the product is and what the sum is. Because when you distribute, this is what we get. That last number is the product of these two. And then this is just the coefficient of this term is the sum of those two constants. Or it can be a variable sum. Awesome. So when we factor this, as we're just doing the opposite of distributing. So what two values are going to, product is going to be 0, but they're going to sum up to be a negative 4.
Negative 2 and negative 2.
That'd be negative 4 and 0. That'd be negative 4 and 0. Negative 4 times 0 is 0. And then when I combine these two, 0 and negative 4 gives me that negative 4. Questions? Yes, sir?
Would it also be positive 2 and negative 2?
No, because positive 2 and a negative 2, their product, when I multiply them, their product is a negative 4. So that would have to be out here. But what you're solving for right now is 0 equals x squared minus 4. This is what you're solving for right now. So that would be x squared plus 0x minus 4, where their product is a negative 4 and they sum up to be 0. That would be those answers. This is different. For ours, they need to sum up to be a negative 4, and their product needs to be 0. So the only answer will be negative 4 and 0. But we're still not done because we don't have x equals something. We don't have that yet. So we need to set these two guys equal to 0, applying the 0 product rule. And so we get x is positive 4 and x is 0. So when you solve it this way, treating it like a quadratic, you will see that you get two solutions. This is what you need. You need to make sure you see both solutions to this equation. Because if we were to graph this, that means this parabola is going to cross the x-axis at the origin at 0 and at positive 4. So if this was my y-axis and x-axis, it would look something like that, where this is x equals 0 and this is x equals 4. That's what the graph would look like. Okay, we got time for one more on this page, if we need it. Okay, we're going to go to the next page. The next page that you had problems assigned was 202. Any questions on 202? For number 11, what were you missing to be able to write the equation of that circle? Yes, sir?
No length of the radius.
Yeah, you didn't know the length of the radius. So you needed to use what to find the length of the radius? Distance formula. Cool. All right. Same thing on the next page for number 13. It was the exact same question, just different coordinates for the center and different coordinates for the point that is on the circle. But we have h and k, we have the coordinates of our center, but we don't have the length of the radius, and so you need to use the distance formula. Because by definition, a radius is a segment whose endpoints are the center and then a point on that circle, anywhere on that circle. So if they give us the center and they give us a point on the circle, then we need to find the distance between those two so we can find the length of that radius. So that's what you have to do on number 11 and 13. And did I assign you guys 15? Yeah. Okay, cool. Same thing on 15 as well. Fine. Awesome. Wait, any final questions about this workbook page packet? Okay, we've wrapped it up. However, I don't want it quite yet because your next test is going to cover this material. So I'm going to let you keep it so that when that test gets closer, you can review yourself. And I'll probably add more problems from it. So put that in a safe place.